So now see a circular current loop as magnetic dipole. So we have already done, if there is a current carrying loop like this of radius r at a distance x at any point on its axis, magnetic field B is given to us, that is a mu naught I r square upon twice of x square plus r square raised to power 3 by 2. This is the magnetic field at this point. We have already calculated using Biot-Savart law. If you are taking x is much more greater than r, it means r can be ignored in this case, this r square and then k whole raised to power, that is a 3 by 2. So we can ignore this r. So we will be getting B is equal to mu naught I r square upon twice of x cube. Now we multiply by pi here, so we can write mu naught I pi r square divided by twice of pi x cube. This pi r square is equal to the area of the loop. So we can write mu naught I a upon 2 pi x cube, and this can be written I into a, that is magnetic dipole moment. So mu naught m upon 2 pi x cube. So capital M here I have taken for the symbol of the magnetic dipole moment. Now come to this point, just take this point again. So we can write here B is equal to, we can multiply by 2 and divide by 2 also. So we will be getting mu naught 2m divided by 4 pi x cube. So see here in this one, this is the magnetic field at any point on the axis of the circular loop, and this one where mu naught upon 4 pi is constant, m is magnetic dipole moment, B is magnetic field axis distance. If you recall the electric dipole, in electric dipole we have calculated electric field intensity at any point on the axis of the dipole, that was here, there. It is twice of P divided by 4 pi epsilon naught r cube. So actually these two expressions are similar to each other. Here is the m is magnetic dipole moment, P is electric dipole moment, x is the distance, r is the distance, mu naught upon 4 pi is constant, and here this one upon 4 pi epsilon naught is constant. And also here we can take mu naught, actually here tends to 1 upon epsilon naught. Whatever is the rule of the mu naught here, that is the rule of 1 upon epsilon naught. Similarly, we can show magnetic field at a point on the perpendicular bisector of the dipole, magnetic dipole, can be calculating mu naught m upon 4 pi x cube, whereas at the equatorial line of the electric dipole we have already done E is equal to P upon 4 pi epsilon naught, here r cube. So again there is a similarity between these two expressions. So actually this part is the similarity between the magnetic dipole and electric dipole, and also here we know it, the current carrying loop behaves as magnetic dipole.